Professor Pelton. This is part 2 of chapter 3, section 2. So now we're going to go through the families of functions. They're the basic families of functions, of the common ones. There are an infinite number of families. We're going to go through the basic ones. So the parent function is the most basic function in a family, where least number of terms and coefficients are used, and the parent preserves the basic shape of the entire function family. Functions in the family are transformations of the parent function. Okay. So for following examples, we're just going to do each of the parent, the most basic function in each group, basically. All right. And we'll be covering transformations in latter sections. So the constant function is the easiest one. So constants can be any number, right? So in this case, we'll do 1. So no matter what I plug in, because I can plug in anything I want for an x value. Okay. So let's say that I do f of -2, I still get 1, right? No matter what I plug in, the outcome is always 1. That's why it's constant. It's constantly 1. So at -2, I'm at 1. At -1, I'm at 1. At 0, 1, 1, I'm at 1. And of course, I can plug in anything I want for an x value. So this is continuous. Okay. Goes on forever left and right because I can pick any x value I want, but y is always 1. So my domain is forever left and forever right, which you can't get to infinity, but the range is a finite or discrete, right? So you just get a singular 1 value. Okay, linear or line. So no matter what I plug in, -2, -1, 0, 1, and 2. So if I plug in -2, I'm going to get -2 to the first power, which is -2. And if I repeat that, I'm just going to get the same numbers based out. Okay, so at -2, I'm at -2. At -1, I'm at -1, 0, I'm at 0, 1, I'm at 1, 2, I'm at 2. And again, I can pick any x value I want. So this is just a line that goes forever in both directions. And that line will move up and down and increase and decrease the slope depending on how you modify the function, which we'll do later on. But this is the most basic linear. So it goes forever left, it goes forever right, it goes forever down, and forever up. Okay. All right, let's try a couple more. So next is the quadratic function, which is x to the second power. We just did linear, which is x to the first power. So I can pick any values I want. I'll keep these pretty basic again. Okay, so if I plug in -2, I'll get -2 squared, which is 4. So if I plug in -1, I'll get 1. I'll plug in 0, I get 1. Plug in 1, I get 1. Plug in 2, I get 4, right? So my graph is at -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So every quadratic looks like a horseshoe essentially. And again, it's continuous because I can pick any values between -2 and 2 or beyond those, of course. So this is going forever left and forever right, but it's only going down to 0, but it's going up infinitely as far as domain and range. Okay. Then we have the exponential function. So 1 to the x is not the basic one because 1 to the x is just always 1, obviously. So 2 to the x would be the next most basic one. So I can plug in any values that I want. -2, -1, 0, 1, 2. Okay, so if I do p to the -2, I'm going to get 2 to the -2, which is 1 over 2 to the 2, which is 1/4, right? So that's 1/4. Okay, that's 1/2. 2 to the 0 is 1, 2 to the 1 is 2, and 2 to the 2 is 4, correct? Right? So I just did 2 to the -1, which is 1/2. Okay, so at -2, I'm at 1/4. Then I'm at 1/2. Then I'm at 1. Then I'm at 2. Then I'm at 1, 2, 3, 4, right? So if I think back, it goes 1/2, 1/4. That's going to be 1/8 and 1/16. So this is going to be right down here on the line. right? It's kind of an exponential growth. And this is supposed to tail off. Okay, it's going to get infinitely close to the axis, but never get there, because obviously the next one, if I plugged in -3, right? If I think about that, it's going to be 2 to the -3, which is 1 over 2 to the 3, which is 1/8, right? Because it goes 1/8, 1/16. So it continually gets smaller, but never gets there. So it's asymptotic, meaning there's an invisible line here you can never cross, right? Which is y equals 0, you can never cross. So I'm going forever left and forever right. However, I'm only going down to 0, but I can't get to 0. I'm trying to get to 0. I can't get there, but I can go up infinitely, essentially. And that's the crux of the exponential function. Okay, so pause the video. Try these student problems for yourself on page 9. Okay, so the cubic function is -2, -1, 0, 1, 2. And again, you can use any values that you want, but obviously choose something easy that actually fits on the graph. So f of -2 equals -2 to the third. That would be -8. The next one's -1, 1, right? Because anything to 0 power is 1, right? And that'll be -2 to the 1 is -2, and then what did I just do? Shoot. I messed that up, I think. Let me double check here. Yeah. Okay, I'm sorry. So 0 to the third is what I should have plugged in, right? So that gives me 0. 1 to the third is 1. And then 2 to the third is 8. I'm sorry, I was doing the previous problem still in my head. Okay, so at -2, I'm at 8. So that's going to be off the graph, which is fine. At -1, I'm at -1. It's -8. Sorry, -8. That's wrong. 0 at 0. 1, I'm at 1. And then 2, I'm at 8. So we got them off the graph on the other side. Okay, so that's a cubic. Makes like a swoosh. So it goes forever left and forever right. It goes forever down and forever up. Okay, and most odd functions look that way. All right, so the absolute value, we'll go -2, -1, 0, 1, 2, and again, you can pick anything you want. So if I take the absolute value of any number, right, I'm going to get the positive. So I get 2, -1, 0. I'm sorry, why did I put a negative on there? Uh-oh, there we go. 1 and 2. Okay, so -2, I get 2. -1, I get 1. So basically, it looks like two lines, essentially. That's why it's called an absolute value, right? It's a V. Okay, so it goes forever left and forever right, but it goes only down to 0, which includes 0, but it goes up forever for the range. Okay, let's try the next two. All right, we have the reciprocal and reciprocal squared. These are the tougher ones. So if I try these, right, so I'm going to get -2, -1, 0, 1, and 2. So I'm going to get 1 over -2, 1 over -1, undefined, right? 1 over 1, and 1 over 2. Okay, so at -2, I'm at -1/2. At -1, I'm at -1. At 0, I'm undefined. 1, I'm at 1. And 2, I'm at 1/2. Well, that's not really much enough like for a graph, so you got to keep thinking what's going to happen. If I plug in 3, I'll get 1/3. If I plug in 4, I'll get 1/4, right? So essentially what's happening is it's asymptotic. It's going to go this way, correct? I'm never going to get to 0. So if I go the other way, I get -3. I get -1/3, next one's -1/4. So this is asymptotic. It's going this way, right? Oh, I'm at the negatives. I'm sorry. That's on the reverse side. I wrote negative, but then I drew positive. I'm sorry. So at -1, I'm at -1. At -2, I'm at -1/2. And then 1/3. All right. So it's asymptotic. again, going up to 0. So if an invisible line here of y equals 0 we can't get to, because it's going to be 1/3, 1/4, 1/5, 1/6, never gets there. The question is, what about the other way, right? Well, there are many values between 0 and 1 and -1 and 0 we didn't do. So all we know is we can't do 0 because 1 over 0, right, is undefined. Well, let's say we do other values like 0.5, right? Well, 0.5, 0.5, right? And negative 0.5. What if I did those ones? Okay, well, what's 0 divided by 0.5? Well, that's 2, isn't it? So at 0.5, we're at 2. And at negative 0.5, we'd be at -2. Okay. And what you notice is if I keep doing values that are closer and closer, right, divide by 0.25, that'd be 4, correct? 1 over 0.25, it'd be 4. So the closer that I get to 0, the bigger the number gets, right? So do 1 over 0.1, you get 10. So no matter how close I can get to 1, it gets to get bigger and bigger and bigger, correct? So it's getting bigger and bigger infinitely, right? And it's getting bigger and smaller infinitely. So it's also asymptotic this way, meaning you cannot cross this x equals 0 invisible line, essentially. Okay? Because I can always pick numbers that are closer to 0, but never actually get there. So it goes forever, so this forever left to 0, right? Union. Actually, write these down. Let's write these down below where I have some more room. It's because it's going to be a union one. We have to put pieces together because there's a jump from 0, basically. So this is negative infinity to 0, union 0 to infinity. So it's basically everything except 0, because left to right, you can't be 0. It can be anything else, though. So range up and down, it goes forever down, up to 0, and then 0 to infinity. But again, we're not including 0, because again, it cannot reach x0 or y0. Okay, so 1 over x squared, we'll do something very similar. We'll do -2, -1, 0, 1, and 2, right? So this one will be a little bit different, because if we do this one, it's 1 over -2 squared. I get 1/4 positive. And this one's also going to be 1/4. And if I plug in 1, I'm just going to get 1. And this is also going to be 1, right? Because if I square a negative. And if I plug in 0, I get 1 over 0 squared, which is still undefined. Okay, so at -2, I'm at positive 1/4. At -1, I'm at positive 1. At 1, I'm at 1. And at 2, I'm at 1/4. Okay. All right, so it looks like a very similar graph. So let's think about what happens. If I plug in 3, I'm going to get 1 over 3 squared. So I'm going to get 1/9, right? So these are going to continually to go smaller and smaller and smaller this way. And these are going to continue to get smaller and smaller this way. This in the same way, because so I cannot cross this invisible line again. I can never get below y equals 0, essentially, right? These are asymptotic. Okay, so vice versa. If I plug in numbers that are close to 0, like 0.5, right, I'm going to get 1 over 0.5 squared, right, or 1 over 0.25, or I'm going to get 4, right? So these are going to get continually higher and higher and higher as I get closer to 0 for another asymptotic behavior, where I cannot, in fact, cross x equals 0. Okay, so my domain, I can go forever left all the way to 0, not include 0, then go from 0 to infinity left and right. So up and down, I can't get down to 0 or below 0. So it's 0 up to infinity, but I cannot go to 0. I can't actually get there up and down. Okay, so last two is the square root and the cube root. Okay, so if I try the square root, I don't know, we'll just try some different things here. -4, -2, -1, 0, 1. 2, and 4, correct? Well, I can't do a square root of a negative, so these are undefined. Undefined, undefined. The square root of 0 is 0, right? The square root of 0 is 0. The square root of 1 is 1. The square root of 2 is a decimal. The square root of 4 is 2, correct? So if this is 2 and this is 1, then this is 1 point something, correct? We don't really know what that is without doing a calculator or some math by hand, but that's fine, right? So at 0, I'm at 0. At 1, I'm at 1. And 1, 2, 3, 4, I'm at 2. So it goes like this, right? So at 2, I'm at 1 point something, which is right there. But who cares what that actual value is, right? Okay, what's important here is the domain and range. My domain starts at 0. I can be 0, and I go forever to the right. But I can't go left into the negatives. My range starts at 0 and goes up forever. Okay, I cannot go negative. All right, so my perfect cube, I'm going to pick some specific numbers here. I'm going to pick -8, -1, 0, 1, and 8, right? So the cube root of -8 is -2, correct? Because this is -2 times -2 times -2, correct? There's 3 of them, right? So the third root of -2 to the third power is -2. Okay, so this is -1, right? Because the third root of -1, right, is just -1, because this is the same thing as -1 3 times, right? 0 is 0, because the root of 0 is always 0 no matter what root it is, and that's 1 and that's 2, correct? Because the third root of 8 is the third root of 2 to the third, right? Because 2 to the third is 8, so you get 2. Okay, so at -8, I'm at -2. So at -8, I'm at -2. At -1, I'm at -1. 0, I'm at 0. 1, I'm at 1. And then 2, I'm at 8. So I get this graph here. So it's kind of a pinwheel, right? So I'm going forever left and forever right. And I'm going forever down and forever up. Going up and down very slowly, but I am going up and down essentially. And that's my kind of pinwheel here. All right, that's the end of part 2.